Okay, in this video we are going to see how to design a 4:1 MUX using 2:1 MUX. In the previous video we have already designed a 2:1 MUX and tested it. Now we are going to design 4:1 MUX by using this 2:1 MUX. Okay, for that, file, new, cell view, and give a name 4:1 underscore MUX. Ensure view and type is schematic. Press OK. Okay, now you enter the schematic window. Go to create instance, select the library, and my library is VLSI, and the cell is 2:1 MUX we have created in last video, and ensure the view is simple. The side. Okay, to design a 4:1 MUX we need 3 2:1 MUX. Place one here and one here and one here. Okay, I will explain you the function and how it's working. Okay, now see what is the characteristics of a 4:1 MUX. 4:1 MUX has 4 input and 1 output with 2 select line. The one of the select line is this select line and another select line is this, and this combination of this both select line, these two select line are going to be combined. I will show you. Okay, use wire or press W to go to wire mode. This is input 1, 2, 3 and 4. Now the select line, and connect this select line to this and take this select line here. Okay, I am just moving this little. Okay, now the output of this MUX will be connected to the input of this, and the output of this is connected to the input of this MUX. Okay, now we need to simply connect VDD and VSS. Don't connect everything, it will look consistent, so use this method. Just extend a little wire and name that wire, and this is the output. Okay, pin. And now we need to give the name. The direction should be input. Ensure that we can give I0 means input 0, input 1, input 2, input 3, and also VDD, VSS, and we need two select line, S0 or else SCL0 and SCL1, two select line. Press side. Here I need to say something to you. This is not theoretical MUX, this is a practical MUX. In your theoretical section you studied this is input 1 and this is 2 and this is 3 and this is 4th input, but that is not practically applicable. This is your first input and your second input is this, and your third input is this, and the fourth input is this. I will explain you more detailedly. Wait, I need to just place this, and your first select line should be this and your second select line should be this. Okay, I will explain you why I didn't place the pins 0, 1, 2, 3. I am placing the pin as 0, 2, 1, 3. Here is some reason. You see, if you give some signal, for example, if you are giving a signal of 0 to this pin, this select line, 0 means the first output, first input is allowed as an output. If this is 0 means this input is getting an output of here, and this input is getting an output of here. Okay, now here also if you are giving 0 means the first input will be getting, the first output is this here, which means 0 0 means this input will go here and it will come outside. For example, here what is the mistake means, if you see, if you're giving the next select line input of 0 1, okay, here 0 means which will come, this input will come here, and here 0 means this input will come. Okay, now here if you give 1 means what will happen, this will go, this input will get as an output. What is this input actually? This input is actually input I1. If you give this wrongly, you will not get the actual input of the MUX. I think you understand. If not, you need to analyze this wiring deeply. This is not an hard concept to enough more. I think you can understand if what is given here, then what will happen here. It's just like that. You can pause the video and think why it's happening, and this is a new lesson for you. While during a practical MUX, you can always go in an odd and even input formats only, not you will go in normal sequence. For example, for the first MUX, you also you always need to give 0 2 4 6 8 input only. For the second MUX, you always need to give the 1 3 5 7 9 like that input only. Okay, now I am giving the output pin out, hide. If you have something still doubt in this means, you can leave a comment. I will try to explain you in that comment. Okay, now just give wiring names, VDD, VSS, this is my VDD, 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 VSS, VSS and VSS. Okay, fine. Now we need to create a symbol, cell view, from cell view. Ensure from schematic to symbol and press OK. Okay, always VDD, VSS should be changed. VDD should be in the top and VSS should be in the bottom, and the actual MUX symbol has the select lines bottom of the symbol. Just remove this and press OK. We will see something like this. Double tap instance name and give a name of 4:1 underscore MUX. We need to create a symbol of 4:1 MUX. For that I am deleting the existing symbol. Okay, use this line. Connect to VDD, VSS. This is the first signal and this is the second signal pin. Connect your output, and these are your 4 input pins, and place this inside. Now we need to create a boundary. For that, go to create selection box, press automatically, it will create automatically a boundary box for you. Now just press check and save. Here's the CAW window. You can verify 4:1 MUX symbol saved. Okay, now we need to verify. While verifying, you can understand why I am giving the input like this. I think in YouTube there is no video explaining this concept. Okay, I will explain you. Just getting out here. New cell view 4:1 MUX test. Okay, create instance, take a 4:1 mux, hide. Okay, now go to the analog lib, search for VDC, press R to rotate, V pulse, hide. 1 2 3 4. Okay, oh, we need two another pulse because we need to give the pulse for select line, hide. Here one and here one. Okay, now search for the ground, hide, placing this ground here and here. Now just wire, press W to go to wire mode. Connect everything. We need to give an output pin out and ensure the direction is at output. Press side, place it here. Now we need to change the parameters or properties. DC voltage of 0.5 voltage. Okay, this is the first input Q. Voltage is a 0.5. Period is 10 nanosecond. Rise time is 0.1 nano. Fall time is 0.1 nano. The pulse width is 5 nano seconds. Okay, now here Q 0.5. Period is 20 nanosecond. Rise time is 0.1 nano. Fall time is 0.1 nano. And the width of 10 nanoseconds. Okay, here Q 0.5. Period of 30 nanoseconds. Rise time 0.1 nano. Fall time 0.1 nano. Width of 50 nanoseconds. That's okay. Q 0.5. Period of 40 nanoseconds. Rise time 0.1 nano and 0.1 nanosecond. Width of 20 nanosecond. Okay, now we need to give the select line inputs Q, and first the input is 0 0. Okay, okay, we can test it one by one, no problem. Period. Okay, I think no need to declare the period here. This also 0 volt. Okay, I'll check and save. Launch ADL. Need to give some name. Wiring I0, I1, I2, I3. Enter. This is line 0, 1, 2 and 3. Check and save. Launch ADL session. You don't need to change. I already said in previous videos. Don't follow this. Okay, now select your model library. 15 HSpice models. Open, play. Okay. Analysis. Start at 0. Stop at 100 nanoseconds. Step of 0.1 nanosecond. Okay. Now output to be plotted. Select and design. Out. What? Why it's output to be plotted? Select and design. What happened? Okay. uh Click and save. Why it's not plotting? Output to be plotted. Select on design. Yeah, it's plotting now. Okay, run. Get our waveform. I'm expanding medium. Status is solid. Okay, expanding. Okay, now you see this is I0, this is 1, this is 2, and this is 3. If I give 0 0, my output is as first input I0. You see that waveform are similar to this. Okay, now just checking for 0 1 Q. Change this to 0.5. 0.5. Okay, check and save. Run. With medium and stylus is solid. Okay, you see now I give an select line as a 0 1. I am getting the output of second input. The name of second input is I1. We are getting the input output now correctly. If you give the input, I say you previously we need to give the input like even and odd numbers. If you give the output like input 1 I1 I2 I3 I4, then now you will get a wrong output. You see, this is the reason I give an input pins like even and odd numbers. Now I think you can understand this. Okay, I think the video is going too lengthy. I no need to simulate two others. I'm just going to simulate this one only. 1.5. Okay. Q 0 0. Okay. Check and save or run. If I'm giving a 1 0, we need to get an this second input as an output. You see the input of third input is output. If you give a 1 1 as a select line, you will get the fourth input as an output. Okay, I think you can understand the concept of a MUX. This is the difference between theoretical MUX and industrial MUX. Okay, thank you.